Hi, and welcome to Module 6. So far, we've been taking the estimates regression analysis generates at face value, but now we're going to begin to assess these estimates a little more critically. This is because we want to know the probability, the slope that the regression analysis gave us likely resulted from simply random appearances of a connection between the variables or an actual underlying relationship between these variables. So we want to know more now than the regression coefficient, the y-intercept, and simply whether we can create an estimate using regression analysis, because regression analysis creates a problem. We can always generate an estimate based on regression, whether there's a connection between variables or not. So in this case, statistics allows us to identify patterns that we might not be able to see with the naked eye. And that's really helpful, but it also tricks us in some ways into identifying patterns that aren't really there. Humans love identifying patterns. This is what we do. We look for them everywhere. But many times, there's no pattern. Think about superstitions. People seem to think and really want to believe that where they were standing in their living room when their favorite team scored a touchdown makes a difference for how their team's going to play, because they identified a pattern. It happened 2 or 3 times, so they're sticking with it. Regression analysis and the help of SPSS will allow us to determine whether the patterns we identify were likely the result of simple random chance or between relationships between underlying connections of variables here. What we're going to do now is think about something called a p-value. What that means is it's a probability value that SPSS generates after we run a regression equation. And that gives us the chance, a percentage chance, that the slope we found, the coefficients connecting independent and dependent variables, resulted from chance versus some underlying connection. The p-value will take the form of a decimal point number between 0 and 1, but it can be read as a probability. So a p-value of 0.15 means you have a 15% chance that the regression results occurred purely due to randomness. We want to get that number lower. We want less than a 5% chance, based on conventions and statistics, that what we identify as a relationship between variables could just have occurred randomly. So in that sense, after we run our regressions, we're looking for a p-value of 0.05 or lower. If it's high, really high, let's say a p-value of 0.75, well, that indicates a large chance that what we found doesn't reflect any connections between an independent and dependent variable, but just random distributions of data. In other words, a 75% chance of this. We would not want to place our bets on a relationship occurring when there's a 75% chance of randomness. However, when there's only a 5% chance of randomness, or less, 1% chance, 0.01% chance, we start to really like those odds, and we bet on the idea of a relationship occurring between variables, as opposed to just random distribution of data resulting in what appears to be a relationship. I'll see you in the Explain Everything link that follows this module introduction link, so that we can talk about an example and describe how this might work in practice. See you soon. Bye-bye.